In 132 AD, deep inside the court of China's Han dynasty, an inventor named Zhang Heng unveiled a machine that made the emperor's advisors gasp. A massive bronze vessel, 8 dragon heads circling its body, each gripping a metal ball in its mouth. When the ground trembled hundreds of miles away, one of those balls would drop, and a toad sculpture below would catch it with a metallic clang. Earthquakes killed thousands before aid could arrive. Zhang's machine gave the empire hours, time to send rescue before the roads collapsed. No electricity. No sensors. Just pure geometry, gravity, and genius. Centuries later, scientists rebuilt it. The result? Zhang's bronze vessel outperformed seismographs used into the 1900s, detecting quakes faster, with fewer false alarms. But here's what stunned them: the real secret wasn't the dragon or the ball. It was the hidden mechanism inside, a design so elegant that no one could reverse engineer it for 1,800 years. The mystery isn't just how it worked. It's why it worked so well, and why humanity forgot a technology that outsmarted us for nearly 2 millennia. For centuries, no one knew how Zhang's machine sensed the Earth's movements. The records were vague, and the original vessel was lost to time. All that survived were cryptic descriptions: dragons that spit when the ground moves. When archaeologists and engineers finally attempted to rebuild it in 2005, most expected failure. Led by researchers at the Chinese Academy of Sciences, the team used Han Dynasty metallurgy techniques to cast a replica, 6 feet tall, nearly 500 pounds of solid bronze. Inside, they suspended a vertical rod on silk threads, balanced so precisely it could tilt from the faintest vibration. The first test changed everything. Zhang's seismoscope didn't measure earthquakes the way our machines do, it felt them. When the planet shuddered, the pendulum swayed and triggered a lever, releasing a single ball from the dragon's mouth into the matching toad's bowl. It didn't just signal that an earthquake had occurred, it indicated the direction of its source. The physics behind this was centuries ahead of its time. Modern seismographs wait for surface waves, the violent shaking that arrives minutes after a quake begins. Zhang's pendulum caught the P waves, compression pulses racing through the Earth's crust at 13,000 miles per hour. That gave precious minutes, sometimes hours, of early warning. In controlled simulations, Zhang's bronze vessel detected tremors more than 300 miles away. During a magnitude 5 test, the correct dragon dropped its ball within 2 seconds of vibration, with a directional error under 15 degrees. The device worked flawlessly, but the math said it shouldn't have. The pendulum reacted to frequencies modern seismographs would filter out as noise. Think about it: if a second-century inventor could detect earthquakes 300 miles away using bronze and silk, what other, primitive, technologies did we abandon too early? And Zhang's notes suggested something even stranger. He was trying to recreate something older, an ancient technique for reading seismic patterns that even his contemporaries had forgotten. Zhang's own notes hinted at a secret: he wasn't inventing from scratch. Instead, he referenced an older method, one his contemporaries had already forgotten. References in the Book of Later Han describe ground listening, techniques used during the Qin dynasty, though the descriptions are vague. These ancient methods, sometimes called listening wells or earth whispers, reportedly sense tremors through subtle shifts in water, suspended stones, or the ground itself. For centuries, historians dismissed these accounts as poetic metaphor. Yet Zhang's seismoscope suggested functional knowledge lay behind the stories. The device captured imperceptible vibrations and translated them into a mechanical signal with precision that ancient storytellers could never describe. The paradox is striking: the ancients may have understood seismic science at a functional level centuries before formal geology existed. How did that knowledge vanish, especially in a society capable of advanced astronomy and metallurgy? The pendulum didn't just respond to generic shaking. Its design amplified the tiniest pre-shock waves, signals modern instruments routinely ignore as noise. Engineers replicated Zhang's mechanism down to the silk threads, but could not explain why those precise dimensions mattered. Alter the pendulum by even 10%, and the system failed. The precision wasn't accidental. It was inherited. That same bronze shell, the dragon heads, the suspended pendulum, represented not innovation but memory, a 2,000-year-old reminder that seismic wisdom predated seismology itself. Zhang's bronze vessel wasn't just a marvel of engineering. It was a whisper from a forgotten tradition, proof that humanity had already learned to listen to the Earth, then somehow fell silent. Modern seismologists didn't just rebuild Zhang's device, they learned from it. The reconstruction exposed a fundamental flaw in contemporary earthquake detection: modern instruments are designed to prevent false alarms, so they filter out weak signals. Zhang's pendulum, by contrast, accepted all seismic data, treating every vibration as potentially meaningful. In ancient China, there was no concept of insignificant tremors. A distant quake that might not harm the capital could devastate a border province. Zhang's design reflected that philosophy: better to detect too much than risk missing a critical signal. Engineers comparing the bronze vessel to early 20th century seismographs discovered something unexpected. Instruments used from 1880 to 1935 relied on similar principles: suspended mass, inertial response, mechanical amplification. But when electronic sensors arrived in the 1960s, data began to be aggressively filtered. Zhang hadn't just anticipated early seismographs, he had pioneered the exact mechanical approach Western science independently rediscovered 1,700 years later. The difference: his version worked in 132 AD, ours took until 1880. The implication is uncomfortable: progress in modern seismology required forgetting what Zhang already knew. His ancient design forces us to question how many critical insights we've filtered out in our quest for precision. Consider this: Zhang prioritized sensitivity over precision, accepting false signals to ensure nothing was missed. Modern systems filter aggressively, risking missed warnings. Which would you trust with your life: total awareness with occasional false alarms, or selective precision that might miss the critical event? Zhang's bronze vessel wasn't just a mechanical marvel, it was evidence of how human knowledge can vanish, even when it saves lives. The techniques he used: sensitive pendulums, mechanical amplification, attention to subtle signals, were rooted in centuries of observation. Within generations, they were forgotten. The pattern repeats throughout history. Roman concrete formulas, capable of surviving seawater for millennia, were lost after the empire fell. Modern engineers only recreated the mixture in the 1990s. Greek fire, the Byzantine Empire's legendary naval weapon, remains a mystery despite detailed records of its use. Damascus steel, forged into blades of unmatched strength, vanished in the 18th century when its makers died without apprentices. Here's the uncomfortable truth: progress sometimes moves backward. Sophistication can obscure what simplicity reveals. Zhang's device worked because it accepted complexity: every vibration mattered. Modern sensors, tuned for precision, filter the very signals ancient engineers considered essential. We've gained accuracy but lost awareness. Civilizations don't advance linearly. Knowledge accumulates unevenly, peaks in unexpected places, then scatters. Brilliant solutions disappear for centuries, rediscovered by accident, if at all. What we call lost technology is often just neglected wisdom, waiting for someone to ask the right questions. Zhang's seismoscope forces a reckoning. If a second-century empire possessed functional seismic detection that outperformed instruments used into the 1900s, how many other solutions lie buried in forgotten texts, dismissed as primitive, filtered out by modern assumptions about what's possible? The answer might be staring us in the face, if we knew how to look. Zhang Heng's seismoscope is more than a mechanical marvel. It's a lesson in observation, humility, and the fragility of knowledge. A 2,000-year-old device, built with bronze, silk, and simple physics, outperformed instruments we'd consider modern centuries later. Yet the principles behind it were nearly lost to time. What does this teach us? Progress isn't always linear. Innovation can obscure rather than reveal. Zhang's bronze pendulum, designed to accept all vibrations, outperformed instruments engineered to reject most. Our obsession with precision filters out signals that, though subtle, carry critical information. Elegance often lies in simplicity, and insight survives only if we preserve, question, and revisit the wisdom of the past. Picture that bronze vessel again: 8 dragon heads circling its body, one ball dropping with a metallic clang. That simple mechanism detected what our complex instruments missed. The genius wasn't in adding more, it was in understanding enough. Today, we face challenges Zhang's contemporaries couldn't imagine: climate shifts, technological disruption, cascading system failures. Yet we approach them with the same blind spots, filtering weak signals, dismissing primitive data, trusting only what sophisticated instruments validate. We're building better sensors while forgetting how to sense. The cost of that forgetting compounds daily. Consider your world. How many overlooked techniques, discarded observations, or dismissed methods could solve problems we struggle with today? How often do we ignore a subtle signal because it doesn't fit the metrics we trust? The next time something is labeled obsolete, pause. Ask what it detected that modern versions filter out. That choice, to look backward before rushing forward, might be humanity's most sophisticated tool.